A warm greetings to one and all. In this session, let's learn about hierarchical clustering. As a part of introduction, we all know that hierarchical clustering is an unsupervised machine learning algorithm which is mainly used to group similar unlabeled datasets into the clusters. It works iteratively by merging the closest points of the data points or clusters until the data points are in a single cluster or desired number of clusters which we require. In k-means clustering, we have faced some challenges. They are, we need to know the predefined number of clusters and it always tries to create the clusters of same size. In order to solve these challenges, we are moving to hierarchical clusters. So here we no need to have the knowledge about the predefined number of clusters. Let's learn about dendrogram. By considering these input data points, we all know that the hierarchical clusters organize the data into the nested structures of clusters, where small clusters can exist within the larger ones, as we have shown in this diagram. Next, dendrogram is a result of the cluster, where it is a tree-like structure that visually represents the arrangement of clusters at different levels. The dendrogram allows one to observe how clusters are being formed, it is being splitted or it is being merged as they move up or down from the hierarchy, and offering the multi-level perspective of data grouping. Here x-axis always represents the data points and y-axis represents the distance or similarity at which the clusters are merged or splitted. There are two types of hierarchical clustering. First, let's check into agglomerative clustering. It is bottom to up approach of hierarchical clustering. It follows a simple pattern of clustering. That is, it begins with each data points as a separate cluster and iteratively merge the closest pair of clusters until all data point belongs to the single clusters or as if we require. Now let's check out the algorithm. So first we have to treat each data point as its own cluster, and then we have to identify the two closest cluster and we have to merge them. We have to repeatedly keep merging the closest clusters until only one cluster remains back. In order to visualize the clustering, we can build a dendrogram, that is tree diagram, to see how clusters were merged. And we have to decide where to cut the dendrogram in order to get the desired number of clusters. The second type of hierarchical clustering is divisive clustering. It is top-down approach of hierarchical clustering. So it always begins with all the data points as a single cluster. We can see here all the data points is being considered as a single cluster and it recursively divides them into smaller clusters until it reaches the each data point which belongs to its own cluster or desired number of clusters is reached. So this is what top-down approach of hierarchical clustering, which is also known as divisive clustering. So the algorithm for divisive clustering is, so we have to begin with all the data points as a single large cluster. Later we have to divide the clusters into two smaller clusters based on the dissimilarities. Then repeatedly we have to keep splitting the clusters into smaller ones. Finally, we have to use dendrogram to visualize the clusters which we have splitted. And we have to decide where to cut the dendrogram in order to get the desired number of clusters. Let's learn about linkage criteria in hierarchical clustering. So the first comes single linkage. It is also known as nearest neighbor clustering. Let's consider two clusters, namely G and H, and the distance between the two clusters is represented using single linkage as DSL of G, H, which is equal to minimum of Di, I dash, where I belongs to the cluster G and I dash belongs to the cluster H. Here, the distance between the two clusters is defined as the shortest distance between the 2 points in each clusters. Now, let's consider the complete linkage. It is also called as forest neighbor clustering. It is defined as DCL of G, H is equal to maximum of a distance I, I dash, where I belongs to the cluster G and I dash belongs to the cluster H. That is here, the distance between the two groups is defined as the distance between the two most distant pair available in the clusters. Finally, it is average linkage. It is defined as the average of G, H is equal to 1 divided by total number of points available in cluster G and total number of points available in cluster H. Summation of I belongs to G and I dash belongs to H, where D I, I dash. So I belongs to the cluster G and I dash belongs to the cluster H. It measures the average distance between all the pairs which is available in the cluster G and cluster H. So hope you are clear on linkage criteria and hierarchical clustering. Thank you all.